to our demonstration on chemical equilibrium. We have set up here for you an analogy for a chemical reaction. We have one bucket that's filled with water and another bucket that does not have any water. Using some vocabulary from earlier this year, the bucket that's filled with water is what we would call our reactants, and the bucket that doesn't have any water in it is what we would call products. And we've learned this year in chemical reactions that reactants form products, and we would indicate that with a yield sign. What you're about to learn today is that many chemical reactions are reversible. In other words, once products are made, they can now reform reactants. And that chemical reaction is reversible, and it happens at the same time. So we're going to be demonstrating these reversible reactions to you, as well as when we reach equilibrium. You were asked a moment ago, what does chemical equilibrium mean to you? And I'm sure you would say in this analogy that chemical equilibrium would be reached when the water levels in the two buckets are equal. So we're going to do our demonstration now to see if your definition's right. All right, let's do the forward reaction where reactants make products. Awesome. There cannot be a reverse reaction at the very beginning because there are no products that can form reactants. But now that I have products, we can now do the reverse reaction. The products can now form reactants. We just showed them to you as one and then another in terms of steps, but these actually happen simultaneously. So for the rest of the demonstration, we're going to be doing the forward and reverse reactions at the same time. Here we go. And remember, we're going to continue this until chemical equilibrium is reached. I don't know about you, but my hand's tired. Let's wait for a second. Oh, take this out. Are the water levels in our bucket equal yet? Nope. Still not at chemical equilibrium. Let's keep going. Oh, I feel like we could be here all day. Are not the same. However, our water levels are not changing. So that means that we really are at chemical equilibrium. Even though the water levels aren't the same, what is equal is the amount of water that we're transferring from one beaker to the other. In other words, the forward reaction is equal to the reverse reaction. When that happens, chemical equilibrium is established. In this instance, in our example, which bucket has the greater quantity of chemicals? The answer is the reactants do. This is a scenario where the reverse reaction is favored. In other words, more products are forming reactants than reactants are making products. If the water levels were opposite, then we would have the scenario where the forward reaction is favored, where reactants are making products more than products are reforming reactants. And we could have a third scenario where the forward and reverse reactions are favored equally. And in this one instance, that's when the water levels in our beaker would be identical. So to sum up chemical equilibrium is dynamic, meaning it's constantly going on and on and on and on at all times. When it's established, the rate of the forward and the rate of the reverse reactions are the same. They may not always have the same favorability. Perhaps, like in our case, the reverse reaction is favored. That would be the example of a weak acid or a weak base where it's not fully dissociating. Or perhaps the forward reaction is favored. where your strong acids and strong bases are dissociating totally. Or we have forward and reverse reactions favored equally. How is it that we can tell which of these three scenarios occurs in a chemical reaction? That's what the rest of the lecture is about. Thanks for watching.